Okay, here we go. Intervention number 10. We have made it to double digits, and we are going to look at a topic which, through the years that I have been marking exam papers, is one that examiners often quote as being one of the ones which students typically don't do as well in as they could do. And the reason why is that students generally look to overcomplicate the problem. They don't take the problem at face value, and they will typically forget to use things that will make the problems significantly easier, and I do mean significantly easier. So we're going to take a look at this. We're going to take a look at some example problems, some keynotes, and then we're going to try and put it into practice. So the first things that we need to know, and we do need to know these two equations, formulas at the top of the screen, those are crucial for us to doing this topic efficiently and doing it well. Okay? So the total internal degrees of a polygon, and that can be any polygon, it doesn't have to be a regular polygon, it can be irregular, is the number of sides take away 2 times by 180. Okay? The reason why this n take away 2 comes from is because that is the number of triangles you'll be able to fit inside that shape, and it's always 2 less than the number of sides. The other formula that we've got is that the external angle of a regular polygon is 360 divided by the number of sides. Okay? Now, the second one only works if it's a regular polygon. Okay? If all the angles and sides are the same. If it is not a regular polygon, that formula does not apply. Okay? But for the top one, that will apply to any polygon, any shape that is made just up of straight sides. Okay? Other things for us to be aware of. We have that an isosceles triangle will have base angles which are equal. So if I have a triangle like this, and I know that these two sides are the same, I know that these two angles here will also be the same. And the angle where the two equal sides meet, that one will be different. Okay. The second thing is something that isn't as obvious as it could be until you look at a circle. Can you imagine if we've got a center point to a circle there? My radius to that circle will be the same no matter where around that circle I go. That's kind of obvious. Okay, that radius will be the same no matter where it goes. But what will also be the same is that if I take a regular polygon, that it will always, from the center of that regular polygon till the edge, and I didn't quite line it up right there, but you can see the idea, from the center to each vertex will also be the same length. Okay, so I can tidy up my radius on that side now. So it should have come down like that. Okay? Those two lengths will be exactly the same. It won't be the same to the middle of a side, but it to the vertices, they will be exactly the same. What that means is that we can make little isosceles triangles all over the place. That can also be useful. It's not as kind of useful as those two. Those two things are essential. But this is quite helpful, especially in some problems. Okay? So, let's take a look at some example problems and see if we can apply this information. Okay, so I've got a shape. I've not written down that this is a regular shape. This is a regular shape. This is regular. Okay, it did say that in the question, but apparently I've not copied that across. Okay, So we've got a regular 1, 2, 3, 4, 5, 6, 7. A regular 7-sided shape. Okay. Very good. Now, strategy number 1. Okay, strategy 1. Find out what you can. Okay, and that sounds a bit ridiculous. Find out what you can, or what do you expect me to be able to do? What I mean by that is if you know how many sides a shape has got, find out what the total angles are. Find out what an external angle is. Maybe those two things will be helpful for you to work out some stuff with this problem. Okay, so let's go for the total internal angles first. So it's a 7-sided shape, so I'm going to have 7 take away 2, and then times by 180. Well, 7 take away 2 is 5. 5 times 180 is 900. So there are 900 degrees in total inside that shape. Fair enough. It's a regular shape. Okay. Because it's regular, I can divide that by 7 to find one of those angles. Okay? And we can do that because it's a regular shape. All of these angles here, all of these angles are going to be the same. Okay? I'll give them the letter Y. We've not used the letter Y yet. All of these angles will be the same because it's a regular shape. Okay? Just as all of these sides are going to be the same because it's a regular shape. Okay? Now, I can't do 900 divided by 7 in my head, so I'm just going to rely on my calculator. 128.571. Okay, so I've worked out 2 bits of information there. I don't know if that's going to be useful to me later on, but it could be. And let's work out the other thing that we can while we're here. So the external angle will equal 360 divided by 7, the number of sides. Okay, now this is going to be a decimal as well. So 360 divided by 7, 51.429. Now, just something to note here. One internal angle and one external angle should add up to make 180. Okay, that's a little kind of just extra fact. Okay, one internal angle and one external angle will always add up to make 180. Okay. Strategy 2. Draw on your diagram. Okay. Your diagram is there to help you, not just to help you visualize, but to help you kind of get through the problem as well. So let's think. An external angle would be this bit. Okay, which is, what was it? 51.429. Okay. This angle here, which is my internal angle, was, what was it? 128.571. Now, this, I would say, has got me somewhere with my problem. It doesn't look like it at the moment, but it has. Okay, we know that that angle X there will also equal this angle x here, because this is an isosceles triangle. Which means that if I was to create another one, I'm going to have another go at that. Oh, why isn't that disappearing? Okay, never mind. We're not going to have another go at it. We're just going to live with it. Oh, sure. There we go. Just taking a mick out of me there. There we go. It's also going to be that angle there. Okay, because if that angle is the base angle of the isosceles triangle, that's just going to repeat all the way around. So what this means is that internal angle here is going to be the same as 2 of those x angles. So 2x equals 128.571. Okay, so, you might not think just from finding out what you can that you could get to this step, but I can guarantee you that there will be some marks for finding some of this stuff out in strategy 1, finding out what you can. Okay, there will be some marks for doing that. And, we just finish off that problem. Dividing by 2 is 64.2855. Okay. Other thing I would say, always check to see what the question is asking you to round to. Okay, I have seen people lose marks because they have not rounded to the appropriate number of significant figures, which is infuriating. Okay, not just for me, but it would have been infuriating for you had you done it. Okay, so let's say that this was rounding to 3 significant figures. Okay, there's my 3 significant figure cutoff. This would be 64.3 degrees to 3 significant figures. Okay? And, that's an ideal kind of exam question. It's not too long that it's kind of like wasting exam time. It's to the point that it needs the information that you will have learnt, and it requires you to take a little bit of problem solving. That is an ideal exam question. Okay? Now, what I'm going to do here now is I'm going to put a second problem up for you to try as part of the video part of this. Okay? Know your formulas. Find out what you can. Draw things onto your diagram. Okay? It will help you no end. Okay? Here we go. Here's your picture. Okay? I'm going to give you a chance to pause the video at this point. I'm going to give you like a 10-second window, and then I'm going to go through it as a second example problem. I should have like some elevator music in the background while people pause, and then they were going to go through the problem now. Okay. So, hopefully you've had a go at this, because if you haven't had a go at it and you're just jumping straight into looking at this, you're missing out on an opportunity. But, here we go. Strategy 1. Find out what you can. Okay. Let's see. How many sides have we got? 1, 2, 3, 4, 5, 6, 7. It's another 7-sided shape. Maybe I should have varied that a little bit. Whatever. We've got 7 sides. Let's go for our total internal angles. It's going to be 7 take away 2 times by 180, which we know is 900 degrees. We also know that one internal angle, because this is a regular shape, it's going to be 900 divided by 7, which we said last time, and I have forgotten, is 128.571. Again, I don't know if I'm going to need that information. I'm just finding out what we can. And we've also got that the external angle is 360 divided by n, or 360 divided by 7, which we said was 52.429, I think we said, did we? Yes, we did. I can remember that one, apparently. Right, I found out what we can. I have not found anything else, so we may as well jump on to a strategy. Nope. Strategy 2. Draw. Okay. So let's draw some things onto our diagram. I can't really that easily draw the total internal angles onto the diagram. That's generally a piece of information for you to keep just in case you can add all the angles up at the corners of your larger shape. What we do have, though, is we have that this angle here and this angle here are both going to be an internal angle. So these are both going to be 128.571 degrees. Now we also know that this is a regular shape, okay? Which means that all of the sides in that shape are the same. Now, hold up 1 second. What I do have here are 2 isosceles triangles, which means that we can work out what these angles in green are. Okay? We know that for an isosceles triangle, angles add up to 180, so I'm going to do 180, take away 128.571, and then that divided by 2. That is going to give me what each of those base angles is going to be. So 180 take away 128.571 divided by 2 is 25.7145. That's each of those green angles. But now I am after this angle x, which hopefully we can recognize as an internal angle, take away 2 lots of those green angles. I'm going to have to go red from this one. So I'm going to have 128.571 take away 2 lots of 25.7145. And that will give me my answer. That will give me what x is equal to. So let's type that in. Take away 2 lots of 25.7145 is 77.142. And let's say we're going for 3 significant figures. 77.1 to 3 significant figures. Okay. These are exactly the kinds of problems that you may have to work with. Okay, finding internal angles, finding external angles. We didn't use the external angle for this, but we may have needed it in working out an angle which is formed outside of a shape. Okay, possibly. My advice for these is breaking things down into those 2 strategies. Find out what you can. Even if you're not sure if it's going to help you, find out what you can. Strategy 2, why can't I say that today? Strategy 2, draw things onto your diagram. Okay? I have seen questions as well that involved lines of symmetry. So reflecting, making sure that everything is drawn on your diagram that you need. Okay? Sometimes these questions are linked in with solving equations, in which case you may have to think, okay, what is the sum of the angles in that shape? What would that be if I wrote it as an equation? what should that equation equal? Okay, and that's normally where things like your total internal angles come in. Okay. You normally use that if you're setting up some kind of an equation. So like, 2x plus 2x plus 10 plus 30 plus, and then whatever else, equals the total amount of degrees inside that shape. Okay? Hopefully this has been a little refresher in terms of how we go about the problem side of these things. Okay? If you're looking for something about the kind of algebraic side of this, bear in mind your algebra skills, especially your simplifying, and then, include the information that we have here. Okay, the total internal angles being the key one. Okay. The questions that you find in GCSE higher to do with these are normally problem-solving questions. They're normally worth 4 to 5 marks. Okay, and if they're worth 5 marks, you may be asked to be giving reasons. Okay, in which case we would need to verbalize things like base angles in an isosceles triangle are equal. Okay, isosceles triangles have two equal lengths, 2 equal angles. Angles in a whatever add up to this, and just writing things out a little bit more. Okay. So there is an attached worksheet with some applying questions on it, which are also really good problem solvers and things like that. And hopefully, this will, give you a little bit more of a start with this topic. Remember to upload anything that you do to your student folder. I check it for our whole class feedbacks and everything like that. So, yeah, show me what you can do. I will see you in the next one, which would probably be averages. Ta-ra.